Hello everyone. Today we have a very interesting question. The question says that if the function f of x is an infinite series like this way, then what is the value of this particular function evaluated at 3 plus square root of 13 whole upon 2? So on the first look the question looks interesting, and it is. And anyone with a basic maths knowledge has figured out that putting the value of x directly as 3 plus square root of 13 in this particular series is not the most clever way to solve this particular question. And the most clever way is to either find this particular series as some sort of function whose expansion is this, or do some kind of arithmetic. Now what I am basically mean to say is that you know the expansion of e raised to x, and it says it goes like 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial, and so on. So for an instant, if somewhere it was given that f of x is this particular expansion and they have asked the value of f of 5, so one may do a solution that they can condense this series as e raised to x, and hence they will get the value of f of x as equals to e raised to x, and clearly f of 5 would simply turn out to be e raised to 5. So putting the value of x in any series is not a clever way to solve the solution. Instead, try to find the shorter form of that series, and in that you can simply put the whatever desired value is asked. So the same motive will be done over here, and to do so we need to first of all find the pattern in this particular expansion or the series. So let us just write it down over here again as sorry for this gray color type question. So now just writing in white color. So f of x has been given as f of x equals to 1 plus 3 upon x plus 7 upon x square plus 17 upon x cube plus 41 upon x raised to 4 plus 99 upon x raised to 5 plus 239 upon x raised to 6, and so on. So the first thing, now, whenever I am solving a question, I always tell you that what was the thinking process and what was the things going on in my mind while saying this question. So the first thing that I thought was why so many terms are given. 2 and 3 terms are maximum, 4 terms are maximum, why so many terms are given? So I just thought that there is some kind of very random pattern, that's why they have given so many terms, so we can figure it out. And while all you need to do is just take a pencil, eraser, pen, pencil, whatever, take a paper and stare at the question. Don't do anything. The best way to solve any question is just stare at it and think of it. So the thing that so sorry, not the thing. So the pattern that I figure out was somewhat like this way. uh, just keep these two terms as it is. The pattern what I thought was starting from this third term. Look closely at 7. Is it 2 times 3 plus 1? Okay, that's nice. 2 times 3 6 plus 1 7. What about 17? So it is looking like 2 times 7 14 and plus 3 gives us 17. Then what about 41? It looks like 2 times 17 and plus 7. Then what about 99? It's look like 2 times 41 plus 17. Then what about 289? Sorry, 239. It looks like 2 times 99 and plus 41. So still if you have not figured out and just thinking what if the random numbers I am writing, so look carefully. Let's talk about the first thing. So look in the 7. So 7 was having a pattern 2 times 3 plus 1. Look carefully, 3 is just the previous term and 1 is the second previous term. For 17, 2 times the 7, that is just the previous term, plus 3, that is again the previous term. For 41, 2 times 17 means 2 times the previous term and add the previous to previous term. For 99, 2 times the previous means 41 and then add the second previous, that is 17, and same goes for 239. So leaving the first two terms, and even this pattern works for 3 also. Look carefully. 2 times previous term, that is 2 ones are 2, and basically that is no more previous term, so we have nothing to add. So that's why I'm saying just leave the first two terms and rest all the pattern works very nicely. So what I can do is I can just write my function in a pattern that f of x is showing a pattern. Leave the first two term as it is, that is 1 plus 3 upon x as it is. Then we have a series in which what we are doing is 2 times n minus 1, not n minus 2. Whatever term we are talking about, just the previous term we are multiplying by 2 and adding the previous term, and in the denominator we have x to the power n. Okay, and n is varying from, look carefully, we are starting from the second term and here we have the x raised to n, so clearly n should start from 2 and go up till infinite. Okay, and what about the a n and this one? So I can just mention over here that a0 is 1, a first is equals to 3, a2 is equals to 7, a3 is equals to 17, a4 is equals to 41, a5 is equals to 99, a6 is equals to 239 and so on. So I have also described what this an suffix whatever that means. Okay, so now you can see that if you just plug in 2, you will have 2 times a1 plus a naught upon x square, and from this table you can figure out that it's going to give us 7. Then for n equals to 3, you will have 2 times a2 term plus the a first term upon x cube. So you can figure out 2 times 7 plus 3. So yes, the pattern what we have made is absolutely correct. Okay, now again I have reached over here, then again stare at this. What can you do next? Just stare. So what I thought is to separate the denominator in that particular summation, and so forth. We will get something like this way, that f of x is equals to 1 plus 3 upon x plus the summation n equals to 2 till infinite 2 times a minus n upon x raised to n plus the summation n equals to 2 till infinite a raised to n minus 2 upon x raised to n. Okay, now just plug in the values of n and see what happens. So f of x will turn out to be 1 plus 3 upon x plus, we can take out the constant 2 out, and inside we will have, and starting from 2 means we will have a1 upon x square plus a2 upon x cube plus a3 upon x raised to 4 plus a4 upon x raised to 5 and so on. Okay, and then for the second summation we will have something like n equals to 2 means a naught upon x square plus a1 upon x cube plus a2 upon x raised to 4, and then we'll have a cube upon x raised to 5, then a raised to 4 upon x raised to 6 and so on. Okay, now according to this particular uh, values I mentioned above, let us plug in these values and see what happens. So therefore f of x will turn out to be 1 plus 3 upon x, we have the 2 outside, inside we will have a1 means 3 upon x square, then plus 7 upon x cube, then 17 upon x raised to 4 plus 41 upon x raised to 5 and so on, and then plus, now starting from a naught means 1 upon x square plus 3 upon x cube plus 7 upon x raised to 4 plus 17 upon x raised to 5 plus 41 upon x raised to 6 and so on. Okay, now okay, so I reached over here, and then what I thought is inside this bracket, do we again have the same pattern as of f of x? Look carefully that f of x is still this kind of expansion. Means wherever you see this kind of expansion, you can name it or you can condense it and say that yes, this expansion is f of x. So look carefully over here, that yes, f of x is equals to 1 plus 3 upon x. Now plus. So what is missing from this pattern and this particular curly bracket over here is that the denominator is having the power of x but 1 greater. So why not just take it common? So inside what we'll have is 3 upon x plus 7 upon x square plus 17 upon x cube plus 41 upon x raised to 4 plus dot dot dot, means infinite terms. Now look carefully over here. It is almost the same pattern. All it is having is x square term extra in the denominator. So we'll take it common. So inside we will have 1 plus 3 upon x plus 7 upon x square plus 17 upon x cube plus 41 upon x raised to 4 and so on. Okay, now look carefully and just try to match this particular pattern with the pattern of the f of x. So it's very clear to say that yes, the second bracket that we have obtained is obviously directly equals to f of x, so it can be replaced as f of x. Now what about this one? So it is almost f of x, all it is not having is the term 1, rest all the terms are as it is, so it can be just written as f of x minus 1, and henceforth we will have a final equation as f of x equals to 1 plus 3 upon x plus 2 upon x multiplied by f of x minus 1, and at the end plus f of x upon x square. Now let us just solve this. So f of x would be equals to 1 plus 3 upon x plus 2 times f of x upon x minus 2 upon x plus f of x upon x square. Now let's solve this further. So first of all 1 as it is, the 3 upon x and minus 2 upon x means 1 upon x, then plus 2 f of x upon x, and finally plus f of x upon x square. Let us take the LCM of x square on the RHS and bring it to the LHS as a multiplication, and so forth. Here we will have x square plus 2x f of x and plus f of x. Bringing the f of x together and grouping it means f of x will be common. We'll have x square minus 2x minus 1, and this thing equals to x common then x plus 1. And finally, we'll have that f of x is equals to x times x plus 1 in the division x square minus 2x minus 1. Can we factor out this particular thing as minus 1? No, no, we cannot factor it out. Yes. So this is the value of the f of x that we have got. That yes, the above expansion can be condensed in this particular pattern. Now recall what we need to find. From this, what was required is the value of f of 3 plus square root of 13 divided by 2. Is what this is what the thing? Yes, 3 plus the square root of 13 divided by 2 and question mark. So now what I am thinking is to just plug in this value, and also I am just thinking of the radius of convergence of this particular power series, that what about that thing. So if they have given this kind of value, means yes, it should satisfy, but there should be a rule, like for example e raised to x, the expansion what we have, so we can plug in any x in that expansion or in this function, they will have the approximate value. But recall the expansion of 1 minus x to the power minus 1. It says that 1 plus x square plus x cube plus and so on. This is the expansion of this particular pattern, means it is summation, and we have nothing but x raised to n varying from 0 to infinite, and here what we have is 1. So using the ratio test or the root test, it can be figured out that the radius of convergence is 1 and not particularly at 1, means the center is at the 0, will have 1 and minus 1. So at 1 or else at x equals to minus 1, at both the values, this one is not going to converge. So x that lies between minus 1 and 1, all the values of x in this particular range, so you can plug in any values from this particular range in this or this, you will get the same result. This is what this says, means if someone tries to put 2, so what he will have is 1 minus 2 the whole inverse, means basically minus 1 inverse, that is minus 1, and here he will have 1 plus 2 square, that doesn't make sense. Okay, so that is why the radius of convergence is important, because a series and a function can be condensed. Okay, but there is some limitation on x, that only for this value of x, the condensed series and the expanded series give the same approximate answer, and that all depends upon the radius of convergence. This is a real analysis topic, and I have studied, I means I am studying, I have studied a little bit of that, or just I am not trying to say that yes, I have studied. And if you want, you can do comment below, I can have some classes on the higher mathematics like linear algebra, sequence and series, root test, ratio test, this radius of convergence, then also group theory, number theory and all that. Okay, all this stuff is just basic school arithmetic, but yeah, this one are the college level maths. So if you want, you can do comment below, and we can have a long playlist of 100, 80, 90 videos explaining all these topics, means like a full course. You can do comment below, and I am ready to do that happily. Okay, so forgetting that, let's talk about the elephant in the room. We need to find the value of f of 3 plus square root of 13 upon 2. So let's plug in that over here. So f of 3 plus square root of 13 upon 2, means we will have 3 plus square root of 13 upon 2 multiplied by 3 plus square root of 13 upon 2 plus 1, means we will have 5 plus square root of 13 upon 2. In the denominator, we'll have to first deal with x square. So what is the square of this particular thing? So it's basically going to be 9 plus 13, that's 22, plus 6 square root of 13, and in the denominator 4. Minus twice, means the 2 in the denominator will go out, and both the sign will become negative, and at the end minus 1. So finally we'll have something 3 plus square root of 13 upon 2 multiplied by 5 plus square root of 13 upon 2, and in the denominator we'll deal with, here this thing will get reduced as 11 plus 3 square root of 13 upon 2. We'll take the LCM, so we'll have negative 6, then negative 2 root 3, or I can just say negative 3 and negative 1 would have become negative 4. So taking the LCM with 2 will give me negative 8. Okay, so this thing can finally give me 11 minus 8 means 3, and then 3 root 13 minus 2 root 13 means only root 13, and in the division 2. So yes, this whole bracket got cancelled out, and finally we have the value of f of 3 plus square root of 13 upon 2 as 5 plus square root of 13 upon 2. Okay, so yes, this is the value that you have got, and also one can make a one can figure out why they have asked the value at only this particular thing, because they wanted to solve, as the upper part was very difficult, all they wanted was to um, make this part easy for the student. So what they have done is they have got this pattern, and they have thought that why not put values of x such that either this or this cancel out, or either this and this cancel out. So if they have thought of cancelling with the value x, so what we have done is x square minus 2x minus 1. They have thought, why not think of some x so that these two values become equal, so they will get cancelled out and the student will easily get the value. So they might have done this, and they have reached x square minus 3x minus 1 equals to 0, and so they have got the value of x as 3 plus and minus the square root of 9 plus 4 upon 2, and hence they have got the value x plus square root of 13 upon 2. This is the value they might have got. Or they can also have the question, means they they can also do some kind like x square minus 2x minus 1 equals to x plus 1. For some x, they can think that what x brings this kind of pattern, so while solving the student will put that value of x and simply get this to cancel out, and he will have a simple value as equals to x. So in that type of situation, one would get equation like this. So x would have a value 3 plus and minus square root 9, then plus 8 upon 2, so x equals to 3 plus square root of 17 upon 2. So if the question was to find at this, yes, the task was easy, and even the question can be asked to find at this particular value, and again the question would be very easy, because now you know that this both will cancel out. That is the main motive to bring this kind of random value. Always think in a problem that why they have given such a random value, 3 plus square root of 13 upon 2. So the main motive or the main idea was to just bring down this particular pattern, so the final task would be easier as the cancellations is easy. But what I think is, one who can solve this, then why to easier this part, let this part also be the on the difficult side. Okay, so nothing to worry about that. Yes, so finally here is the final part that you can just have a look. So it was a very interesting and nice problem, and I do love solving series and sequence question. I really love them solving, and I promise I'll bring this kind of more series and sequence question. So this was one of them. Previously also some are there on my channel, but yes, the previous quality is little on the downer side, but yes, the questions are still interesting. This one is nice. We'll bring more, and the next question is also not a series question, it's an algebraic question, and we can say that it's uh, we can just be a little on the downside and say that it's a few second work for the Asians and a very difficult task for the Americans, as per the memes go. But I don't agree with the memes that it's all basic. Any human with who has interest in mathematics, irrespective of the caste, religion, or the state, or the region, country, nationality he has born, all a student should have is an interest in mathematics, and everything becomes easy and lovely. Okay, so this was my way to solve this particular problem, and yes, the next problem is going to be easier for some people, difficult for some people, but yet it is a nice question. So be ready for that, and this was my way. If you have any other solution, you can do comment below, and if it's a photo or PDF that you want to share, the email address is in the description. Thanks for watching. Bye bye.